Theory of Colors. Theory of Colors is a book by Johann Wolfgang von Goethe published in 1810. The work comprises 3 sections. 1. A didactic section in which Goethe presents his own observations. 2. A polemic section in which he makes his case against Newton. And 3. An historical section. It contains some of the earliest and most accurate descriptions of phenomena such as colored shadows, refraction, and chromatic aberration. Its influence extends primarily to the art world, especially among the Pre-Raphaelites. J.M.W. Turner studied it comprehensively and referenced it in the titles of several paintings. Wassily Kandinsky considered Goethe's theory one of the most important works. Although Goethe was never well received by the physicists, a number of philosophers and physicists have been known to concern themselves with it, including Arthur Schopenhauer, Kurt Gödel, Werner Heisenberg, Ludwig Wittgenstein, and Hermann von Helmholtz. Mitchell Feigenbaum had even convinced himself that Goethe had been right about color. In his book, Goethe provides a general exposition of how color is perceived in a variety of circumstances, and considers Isaac Newton's observations to be special cases. Goethe's concern was not so much with the analytic measurement of color phenomenon, as with the qualities of how phenomenon are perceived. Science has come to understand the distinction between the optical spectrum, as observed by Newton, and the phenomenon of human color perception, as presented by Goethe. Contents. Goethe's theory. 1.1 Historical background. 1.2 Goethe's reasoning. 1.3 Experiments with turbid media. 1.4 Darkness and light. 1.5 Boundary conditions. 1.6 Light and dark spectra. 1.7 Goethe's color wheel. Second section, Newton and Goethe. Third section, current status. Fourth section, quotations. Fifth section, notes and references. There's also a bibliography, see also, and external links. Section 1, Goethe's theory. It is hard to present Goethe's theory since he refrains from setting up any actual theory. Its intention is to portray rather than explain. Goethe and Scientific Studies. For Goethe, the highest is to understand that all fact is really theory. The blue of the sky reveals to us the basic law of color. Search nothing beyond the phenomena. They themselves are the theory. Schopenhauer is now quoted. Goethe delivered in full measure what was promised by the title of his excellent work, Data for a Theory of Color. They are important, complete, and significant data, rich material for a future theory of color. He has not, however, undertaken to furnish the theory itself. Hence, as he himself remarks and admits on page 39 of the introduction, he has not furnished us with a real explanation of the essential nature of color, but really postulates it as a phenomenon, and merely tells us how it originates, not what it is. The physiological colors he represents as phenomenon, complete and existing by itself, without even attempting to show their relation to physical colors, his principal theme. It is really a systematic presentation of facts, but it stops short at this. Schopenhauer, On Vision and Colors, Introduction. Back to the article. The crux of his color theory is its experiential source. Rather than impose theoretical statements, Goethe sought to allow light and color to be displayed in an ordered series of experiments that readers could experience for themselves. As such, he would reject both the wave and particle theories because they are conceptually inferred and not directly perceived by the human senses. Another quotation box by Ludwig Wittgenstein. Goethe's theory of the origin of the spectrum isn't a theory of its origin that is proved unsatisfactory. It is really not a theory at all. Nothing can be predicted by means of it. It is rather a vague schematic outline of the sort we find in James's psychology. There is no experimentum crucis for Goethe's theory of color. Remarks on Color by Ludwig Wittgenstein. Goethe outlines his method in the essay The Experiment as Mediator Between Subject and Object, 1772. It underscores his experiential standpoint. The human being himself, to the extent that he makes sound use of his senses, is the most exact physical apparatus that can exist. Goethe, Scientific Studies. Section 1.1 Historical Background. In 1740, Louis Bertrand Castel published a criticism of Newton's spectral description of prismatic color, in which he observed that the colors of white light split by a prism depended on the distance from the prism, and that Newton was looking at a special case, an argument which Goethe later developed. It was in the 1780s when Goethe was asked to return a prism which had been on loan from the Privy Councillor Büttner in Jena. As he did so, he paused to take a look through the prism, and what he saw led him to a comprehensive study of light phenomenon, culminating in the theory of colors. Goethe is quoted, "Along with the rest of the world, I was convinced that all the colors are contained in the light. No one had ever told me anything different, and I had never found the least cause to doubt it, because I had no further interest in the subject." Goethe. At the time, it was already known that the prismatic phenomenon is a process of splitting up the colorless light into colors. Newton's theory stated that the colorless light already contains the 7 colors within itself, and when we direct this light through the prism separates what is already there in the light, the 7 colors, into which it is analyzed. Section 1.2 Goethe's reasoning. Goethe reasoned, in such a way the phenomenon are interpreted, but this is not the primal or complete phenomenon. A look through the prism shows that we do not see white areas split evenly into 7 colors. Rather, we see colors at some edge or borderline. Steiner, the science editor of Goethe's works, is now quoted. "If we let light pass through the space of a room, we get a white circle on the screen. Put a prism in the way of the body of light that is going through here, the cylinder of light is diverted." Figure 1. But what appears in the first place is not the series of 7 colors at all, only a reddish color at the lower edge, passing over into yellow, and at the upper edge, a blue passing over into violet shades. In the middle, it stays white. The colors, therefore, to begin with, make their appearance purely and simply as phenomenon at the border between light and dark. This is the original, the primary phenomenon. We are no longer seeing the original phenomenon when, by reducing the circle in size, we get a continuous sequence of color. The latter phenomenon only arises when we take so small a circle that the colors extend inward from the edges to the middle. They then overlap in the middle and form what is called a continuous spectrum, while with a larger circle, the colors remain formed at the edges as they are. This is the primal phenomenon. Colors arise at the borders, where light and dark flow together. Goethe therefore concluded that the spectrum is a compound phenomenon. Color arises at light-dark boundaries, and where the yellow-red and blue-violet edges overlap, you get green in the middle. Section 1.3 Experiments with turbid media. Goethe's studies of color began with subjective experiments which examined the effects of turbid media on the perception of light and dark. He observed that light seen through a turbid medium would appear yellowish, and darkness seen through a turbid medium that had been lightened would appear blue. Goethe is now quoted. "The highest degree of light, such as that of the sun, is for the most part colorless. This light, however, seen through a medium but very slightly thickened, appears to us yellow. If the density of such a medium be increased, or if its volume become greater, we shall see the light gradually assume a yellow-red hue, which at last deepens to a ruby color." Theory of Colors, 150. If, on the other hand, darkness is seen through a semi-transparent medium, which is itself illuminated by light striking on it, a blue color appears. This becomes lighter and paler as the density of the medium is increased, but on the contrary appears darker and deeper the more transparent the medium becomes. In the least degree of dimness, short of absolute transparence, always supposing a perfectly colorless medium, this deep blue approaches the most beautiful violet. Theory of Colors, 151. Starting from these observations, Goethe began numerous experiments observing the effects of darkening and lightening on the perception of color in many different circumstances. Section 1.4 Darkness and Light. For Goethe, light is the simplest, most undivided, most homogeneous being that we know. Confronting it is the darkness. Letter to Jacobi. Unlike his contemporaries, Goethe didn't see darkness as an absence of light, but rather as polar to and interacting with light. Goethe is quoted. "They maintain that shade is a part of light. It sounds absurd when I express it so, but so it is, for they said that colors which are shadow and the result of shade are light itself, or which amounts to the same thing, are the beams of light broken now one way, now another. John Eckermann, Conversations with Goethe, January 4, 1824. Based on his experiments with turbid media, Goethe characterized color as arising from the dynamic interplay of darkness and light. The editor of the Kirchner edition of Goethe's works gives the following analogy. Modern natural science sees darkness as complete nothingness. According to this view, the light which streams into a dark space has no resistance from the darkness to overcome. Goethe pictures to himself that light and darkness relate to each other like the north and south poles of a magnet. The darkness can weaken the light in its working power. Conversely, the light can limit the energy of the darkness. In both cases, color arises. Steiner, 1897. Goethe writes, "Yellow is a light which has been dampened by darkness. Blue is a darkness weakened by the light." Section 1.5. Boundary conditions. When viewed through a prism, the orientation of a light-dark boundary with respect to the prism is significant. With white above a dark boundary, we observe the light extending a blue-violet edge into the dark area, whereas dark above a light boundary results in a red-yellow edge extending into the light area. Goethe was intrigued by this difference. He felt that this arising of color at light-dark boundaries was fundamental to the creation of the spectrum, which he considered to be a compound phenomenon. Section 1.6. Light and dark spectra. Since the color phenomenon relies on the adjacency of light and dark, there are at least two ways to produce a spectrum: with a light beam in a dark room, or with a dark beam, i.e. a shadow, in a light room. Goethe recorded the sequence of colors projected at various distances from a prism for both cases. Plate 4, Theory of Colors. In both cases, he found that the yellow-blue edges remain closest to the side which is light, and the red-violet edges remain closest to the side which is dark. At a certain distance, these edges overlap. When these edges overlap in a light spectrum, green results. When they overlap in a dark spectrum, magenta results. With a light spectrum coming out of the prism, one sees a shaft of light surrounded by dark. We find yellow-red colors along the top edge and blue-violet colors along the bottom edge. The spectrum with green in the middle arises only where the blue-violet edges overlap the yellow-red edges. With a dark spectrum, i.e. a shadow in light, we find a violet-blue edge along the top and a red-yellow edge along the bottom. Where these edges overlap, we find magenta. Section 1.7. Goethe's color wheel. Goethe anticipated Ewald Hering's opponent process theory by proposing a symmetric color wheel. He writes, "The chromatic circle, arranged in a general way according to the natural order, for the colors diametrically opposed to each other in this diagram are those which reciprocally evoke each other in the eye. Thus, yellow demands violet, orange blue, red green, and vice versa. Thus, all intermediate gradations reciprocally evoke each other, the simpler color demanding the compound, and vice versa." Goethe, Theory of Colors. Section 2. Newton and Goethe. Due to their different approaches to a common subject, many misunderstandings have arisen between Newton's mathematical understanding of optics and Goethe's experiential approach. Because Newton understands white light to be composed of individual colors, and Goethe sees color arising from the interaction of light and dark, they come to different conclusions on the question, is the optical spectrum a primary or compound phenomenon? For Newton, all the colors already exist in white light, and the prism merely fans them out according to their refrangibility. Goethe sought to show that, as a turbid medium, the prism was an integral factor in the arising of color. Whereas Newton narrowed the beam of light in order to isolate the phenomenon, Goethe observed that with a wider aperture, there was no spectrum. He only saw reddish-yellow edges and blue cyan edges with white between them, and the spectrum only arose where these edges came close enough to overlap. For him, the spectrum could be explained by the simpler phenomenon of color arising from the interaction of light and dark edges. Goethe's reification of darkness has caused almost all of modern physics to reject Goethe's theory. Both Newton and Huygens defined darkness as an absence of light. Young and Fresnel combined Newton's particle theory with Huygens' wave theory to show that color is a visible manifestation of light's wavelength. Physicists today attribute both a corpuscular and undulatory character to light, which is the content of the so-called wave-particle duality. Curiously, since the crux of Goethe's theory is tied to what is experiential, he would reject both the wave and particle theories, since they are conceptually inferred and not directly experienced by the human senses. Newton explains the fact that all the colors appear only when the prism is at a certain distance from the screen, whereas the middle otherwise is white, by saying, the more strongly diverted lights from the upper part of the image and the more weakly diverted ones from the lower part fall together in the middle and mix to white. The colors appear only at the edges because there none of the more strongly diverted parts of the light from above can fall into the most weakly diverted parts of the light, and none of the more weakly diverted ones from below can fall into the most strongly diverted ones. Table of differences. Qualities of light are compared by Newton and Goethe. First quality, homogeneity. Newton, white light is composed of colored elements and is heterogeneous. Goethe, light is the simplest, most undivided, most homogeneous thing. Homogeneous. Second quality, darkness. For Newton, darkness is the absence of light. For Goethe, darkness is polar to and interacts with light. Quality, spectrum. For Newton, colors are fanned out of light according to their refrangibility, primary phenomenon. For Goethe, colored edges which arise at light-dark borders overlap to form a spectrum, a compound phenomenon. Quality, prism. For Newton, the prism is immaterial to the existence of color. For Goethe, as a turbid medium, the prism plays a role in the rising of color. Quality, role of refraction. For Newton, light becomes decomposed through refraction, inflection, and reflection. For Goethe, refraction, inflection, and reflection can exist without the appearance of color. Quality, analysis. For Newton, white light decomposes into 7 pure colors. For Goethe, there are only 2 pure colors, blue and yellow. The rest are degrees of these. Quality, synthesis. Just as white light can be decomposed, Newton says it can be put back together. Goethe contends that colors recombine to shades of gray. Quality, particle or wave. For Newton, it is a particle. For Goethe, neither, since they are inferences and not observed with the human senses. Quality, color wheel. For Newton, asymmetric and comprised of 7 colors. For Goethe, the color wheel is symmetric and comprised of 6 colors. Section 3. Current status. Today, Goethe's theory of colors is still remarkable for its phenomenological observations. Quotation from James B. Judd, introduction from MIT Press. Most of Goethe's explanations of color have been thoroughly demolished, but no criticism has been leveled at his reports of the facts to be observed, nor should any be. This book can lead the reader through a demonstration course not only in subjectively produced colors, after images, light and dark adaptation, irradiation, colored shadows, and pressure of phosphenes, but also in physical phenomena detectable qualitatively by observation of color, absorption, scattering, refraction, diffraction, polarization, and interference. A reader who attempts to follow the logic of Goethe's explanations, and who attempts to compare them with the currently accepted views, might, even with the advantage of 1970 sophistication, become convinced that Goethe's theory, or at least a part of it, has been dismissed too quickly. James B. Judd, 1970, MIT Press. Back to the article. Goethe's claim that color arises from the interplay of light and dark has caused almost all of modern physics to reject Goethe's theory as unscientific. Yet Goethe was consistent in his approach. Quoted now is James Gleick in his book Chaos. As Feigenbaum understood them, Goethe's ideas had true science in them. They were hard and empirical. Over and over again, Goethe emphasized the repeatability of his experiments. It was the perception of color to Goethe that was universal and objective. What scientific evidence was there for a definable real-world quality of redness independent of our perception? James Gleick, Chaos. Developments in understanding how the brain interprets colors, such as color constancy and Edwin Land's Retinex theory, bear striking similarities to Goethe's theory. As a catalogue of observations, Goethe's experiments are useful data for understanding the complexities of human color perception, whereas Newton sought to develop a mathematical model for the behavior of light. Goethe focused on exploring how color is perceived in a wide array of conditions. End of article. Quotations. Section 5. Should your glance on mornings lovely lift to drink the heavens blue, or when the sun, veiled by sirocco, royal red sinks out of view, give to nature praise and honor, blithe of spirit and sound of eye, knowing for the world of color where its broad foundations lie.